I'm going to be going over limit operations, and I'm also going to be going over how to solve limit problems that you'll see on probably test or quizzes algebraically and also graphically. So the first thing I'm going to do is go over the basic limit operations. And so they're pretty much work like normal mathematical operations. So essentially, if I have um, limit as x approaches a of f of x plus or minus g of x, I can just split this into two separate limits and say limit as x approaches a of f of x plus or minus limit as x approaches a of g of x. So I'll be able to take my limit for f of x and g of x, just add or subtract them. Similarly, if I have limit as x approaches a of f of x times g of x, this also works with division. I could split this into being limit as x approaches a of f of x times limit as x approaches a of g of x. These two will be constants, and you can just go ahead and multiply or divide them together. So yeah, limit operations are pretty simple. And so an example you could see on a test or quiz is where they would give you a set of conditions. Limit as x approaches 2 of f of x equals 4. Limit as x approaches 2 of g of x equals 2. And limit as x approaches 2 of h of x is equal to 3, right? And so the problem could be, what's the limit as x approaches 2 of 2f of x times h of x divided by 3g of x? And so we could just rewrite this as being limit as x approaches 2 of 2 times f of x times limit as x approaches 2 of h of x divided by limit as x approaches 2 of 3 times g of x, right? And now I just have to directly plug in my values from the given conditions. So f of x is 4, so 2 times 4. And then limit as x approaches 2 of h of x is 3. And then limit as x approaches 2 of g of x is 2. So 3 times 2. So on the top we'll get 24 divided by 6. And so our final answer will be 4. So that's a kind of problem you can expect to see on your assignments. Okay, so moving on, I'm going to go over now how to solve different limit problems algebraically. And so the first method I want to go over is direct substitution. Direct substitution. And so this is essentially where whatever the x value our limit's approaching is, we plug that in into our expression. And so this is going to be the method you're going to want to try out first, regardless of whatever limit problem you have, just to see if it works. So if I have limit as x approaches 2 of x cubed plus e to the 2x plus x over 3. So I'm going to go ahead and immediately plug in 3. So I'll get 3 cubed plus e to the 6 plus 3 over 3. This simplifies to a constant. I get 27 plus e to the 6 plus 1. So my final answer will end up being 28 plus e to the 6th. And so that's an example where you can go ahead and apply direct substitution. And if you get a constant, then that method will work. Okay, so most cases direct substitution won't work. So if you have an example where you have a radical, and so let's say limit as x approaches 9 of the square root of x minus 3 over x minus 9. So if you look at this example, if we go ahead and plug in 9 directly, we'll get 0 in the denominator. And we'll assume the limit's d/e when it's really not. So what we're going to need to do is multiply this by its conjugate. And so what we can do is say limit as x approaches 9, and we have the square root of x minus 3, right? So by multiplying with the conjugate, we would get the square root of x plus 3. And remember, you have to multiply both the numerator and denominator with the square root of x plus 3 so that you don't change the expression. And now you can go ahead and simplify. So now we'll have limit as x approaches 9 of x minus 9, and then divide that by x minus 9 and the square root of x plus 3. So now we see that in our numerator and denominator we have a common factor. These cancel out, and that's usually how these problems work. You'll end up having a common factor that will cancel out in the numerator and denominator. And so now we can just simplify this to being limit as x approaches 9 of 1 divided by the square root of x plus 3. If we go ahead and plug in 9, we'll get 1 divided by 3 plus 3, or 1/6. So that's our final answer for that problem, an instance where we had a radical expression. Now, the third type of problem you'll most likely run into is where you have to apply common denominator. And so an example would be if I have the limit as x approaches 4 of 1 over x minus 1 over 4 over x minus 4. So again, if I plug in 4 directly, I'm going to get 0 in the denominator. So what I have to do is, in my numerator, establish a common denominator. So within this, I'm trying to simplify it to one expression. So remember, to do common denominator, we really just have to kind of like cross multiply so that we have common terms. So I'll get 4 minus x over 4x, right? And I'll have that divided by x minus 4, and I can just bring that x minus 4 right here. So what I really have is limit as x approaches 4 of 4 minus x. I have a 4x, and I have an x minus 4. Now this looks like we can almost cancel out this factor and this factor, but we have to rearrange our negatives. So if I factor out a negative in the numerator, I'll get x minus 4, and now it matches with what I have in the denominator. Now these two factors cancel, and I'm left with limit as x approaches 4 of negative 1 over 4x And now if I go ahead and plug in 4, I'll get negative 1 over 16 as my final answer. Okay, and then the last method is pretty easy. Essentially, we're just going to have to factor. Okay, so if I have an example where the limit as x approaches 4 of x squared minus 4x divided by x squared minus 3x minus 4. If I plug in 4 again directly, I'll end up getting 0 in the denominator. So I have to try to factor my top and bottom. So if I factor the top, I'll take out an x. I'll be left with an x minus 4. And if I factor the bottom, I'll have in x minus 4 and an x plus 1. And so immediately from this, I know that these two factors will cancel. So now I'm left with limit as x approaches 4 of x over x plus 1. If we plug in our x value now, we'll get 4 over 5. And that will be our final answer. So those are the 4 different methods you'll probably use for solving limit problems. And then those were also the simple operations we went over at the beginning with just addition, subtraction, multiplication, and division. Pretty simple problems. And so the last thing I'm going to go over is finding limits graphically, which is pretty easy. So if I have a question like this essentially, where they give you different curves on the graph, and they're going to ask you to evaluate the limit at different points. So let's just go through this problem quickly. So limit as x approaches negative 2 is the first one. So we go and we approach, we use the curve to approach negative 2 from the left side. So I'm going to approach it from this side. And then we approach it from the right side. So I'm going to approach it from this side. Now this point doesn't have to exist for the limit to exist. And so in this example, we see that if we approach from the left side, we reach the point negative 1. And if we approach from the right side, we reach the point negative 1. As long as our limit from the left side and our limit from the right side are equal, then our limit exists. So in this case, our limit as x approaches negative 2 will be negative 1. Now let's look at this example. The limit as x approaches positive 2 from the left side. So here's positive 2. Here's the x value positive 2, and we're going to go ahead and approach that from the left side. So now if we approach it from the left side, we see that our function is approaching positive infinity. So from the left side, it's approaching positive infinity. Now, let's look at x approaches 2 from the right side. So now I'm going to be coming in to 2 from the right side. And we see that our function is approaching negative infinity now. So now we know that the limit as x approaches 2 from the right is negative infinity. And keep in mind, these two values are not equal to each other. Now, limit as x approaches 2. Well, since we know that the limit from the left side of 2 and the right side of 2 are not equal, we can say that the limit at 2 does not exist. Now let's look at f of 2. F of x just needs to be a point defined on your curve, or on your graph. So if we go at 2, we see that we have a point defined at negative 1. So f of 2 is just negative 1. And then the last question, f of 4. So f of 4, there is no point defined right here. We have a hole, so we can say that f of 4 is undefined. And so that's basically what you can expect from evaluating limits through a graph. And so in this lesson, I went over solving limits algebraically and graphically, as well as basic limit operations. Thank you, and I hope this helped.